Lipids. What are lipids? Do you know anything about lipids yet? Have you ever encountered a lipid? Grab a piece of paper. We're going to need it in just a minute. And let's write down what we remember about lipids. They're the most boring of all molecules. Nobody likes them. I remember falling asleep to lipid papers. You fitting some stuff down? So you should have gotten to fats. From lipid, fats should be the first thing you think. And then when you're thinking about fats, there's a whole slew of things you should be thinking about, right? Or you may be thinking about fats. You're thinking about fats in food, butter, grease that floats on soup, fat as energy source, fat as protection for organs, fat, soluble vitamins, maybe. There's all kinds of things you can think about when you're thinking about fat. If you've never had the biology class, there's the most important lipid you're probably not thinking about, but we're going to talk about it a bunch. But let's first talk about the lipids themselves. Now, if you've heard my spiel before about what is going on with long chains of carbons with a bunch of hydrogens around it, then you should be looking at this going, oh yeah, this one contains a bunch of energy. And it gets better than that, because normally the way these things show up is as triglycerides. And as triglycerides, they show up with 3 fatty acids. So one of those long things is called a fatty acid. 3 fatty acids that's linked to this one here is a glycerol. And that together is a triglyceride. And as you see, tri means 3. So 3 fatty acid. And glyceride, triglyceride, the glyceride part in triglycerol tells you that there's a glycerol in there. Another thing I want you to notice on that particular molecule, that one of these is bent. One of these, 2 of them are straight, one of them is bent. The one that's bent has a double bond right there, because it's missing a hydrogen. If it had a hydrogen there, it would be just H2H2H2 all the way top to bottom, but it's missing a hydrogen there. So this one's got a bend on it. Fatty acids that are missing a hydrogen are called unsaturated, because they're not saturated with all the hydrogen. And unsaturated fatty acids have a bend in them. Things that have bends in them cannot be packed as tightly as things that are straight. If you had a bunch of straight things and you tried to pack them together, that's pretty easy to do. But if you got a jumble of bent things, that's not so easy to do. And this is the reason why saturated fats, the ones with all the hydrogen present, where all the fatty acids are straight, those are, you find those in those are the solid fats. And the unsaturated fats, those are the oils. Those are the bent ones, because the bent ones are the ones that don't pack as tightly. But let's talk about our very extra special little lipid, the most important lipid of all, the lipid that allows us for life to exist, um, because that is the basis of why membranes come together, um, more or less. So this is what's called a phospholipid. A phospholipid has a phosphate. So again, you've got the glycerol, just like you did before. But instead of having three fatty acids, you've got two fatty acids and a phosphate group. The phosphate group, you always, anytime you see a phosphate group, think charge. There's usually a positive charge associated with a phosphate group. So it's charged. And things that are charged, if you've heard my spiel before, how do things that are charged feel about water? Do they like it or do they not? And fatty acids, those are entirely uncharged. How do they feel about water? Do they like it or do they not? Now it's actually already given on the page on the screen, right? Because this head here, it says hydrophilic. Again, that's a word that gives it away. Philic means loving, hydro means water. Hydrophilic is water loving. This thing is charged, and because it is charged, it is water loving. It likes water. It doesn't have a problem with water because water and it, they do mix, in fact. Um, the hydrophobic tail, on the other hand, does not have any charge on it. It is completely uncharged. And so, because carbon is such a friendly little thing that just plays with everyone, and so it does not like to play with water. And so, if you had a liquid and you were to throw a bunch of these guys in it, a bunch of with the hydrophilic heads and the hydrophobic tails, you'd throw them in there. They'd land in here and their little feet would be standing up. If this is just a liquid, right? They're just getting dumped into the liquid. The little feet would be standing up because their little heads would be okay with the water. So the little heads would go in the water and the little feet would be sticking up straight in the air. And they'd probably congregate together, like kind of just float around, like a little fatty eye kind of thing. But now if you shake it, like kind of like salad dressing, like when you shake salad dressing, you have a bunch of lipids, right? And they mix together for a moment, and then they come back apart. Unless you've got like an emulsifier in there, they come back apart. Well, what happens with these little guys? Are they all going to come apart again, just like this again? Are they going to just, if I go, let's say this is in a plastic bag, and just kind of like if you're making ice cream, you're shaking the bag, just grabbing it on the top right here, shaking it up and down, um, and then when you're done shaking, you stop. Are they going to separate back out again, just like they would in salad dressing, or is something else going to happen? And if you want to think some longer, you can pause this video. But what's going to happen is they get together. One of the ways they can get together is they get together in what's called a micelle. Micelle. Where you have the little heads on the outside and the little tails on the inside. That way, all the little tails are protected from water, and all the little heads are close to water. So they build a little structure that is a structure. And if you modify this structure a little bit, to make it a bilayer, where you have, instead of having one layer where you just have the little hydrophobic tails in the middle, but instead you have two layers of hydrophobic things close together, and the hydrophilic thing on the other um, side. What you now have is you have a barrier where something that has, that happens in a watery environment can happen on the inside versus something that can happen on the outside. And so now you can have life. This is the beginning of life. This is why lipids are important for us.